Hello, welcome to the Pendulum Instruments YouTube channel. In this video, we are going to show you the basic usage of our new instrument, the multi-channel frequency analyzer CNT-104S. The four main inputs of the CNT-104S allow simultaneous measurement of up to 4 signals with frequencies up to 400 MHz. In this example, we are going to measure 4 different sources of a 10 MHz signal from frequency standards. Each 10 MHz signal is connected to 4 measurement inputs, A, B, D, and E. Let's check how good those signals are by doing a quick and simple measurement. It's always good practice to reset the measurement settings to defaults when you start working with the instrument. This way, you ensure that most of the parameters have the best predefined values. Since we are going to make a basic frequency measurement, we need the frequency function from the frequency group. This is the default instrument setting. And also select measurement inputs A, B, D, and E. By default, the CNT-104S is configured to produce only one sample. A sample is the result of an individual measurement, and for the frequency function, it is the average frequency measured during the specified time window, given by the sample interval parameter. The bigger the sample interval, the better the frequency resolution you get, but at the expense of longer measurement time. Let's keep the default sample interval of 10 milliseconds and increase the number of samples to get more representative results. Most frequency sources outputting a 10 MHz signal are designed for a 50 ohm load, so we need to change the input settings from the default 1 mega ohm to 50 ohm. Let's first change the settings for input A only. And then copy them from input A to other inputs, so that all inputs are configured in the same way. Even though the CNT-104S allows configuring a lot of parameters, for many use cases you only need to make this minimal configuration and keep other parameters in their default state. Let's exit the configuration menu and return to the main screen. Here we are. The measurement is already running with the specified settings. Right now, the numeric display on the CNT-104S shows the current values of the measurement parameter, frequency. It's worth noting that the 4 inputs are being measured simultaneously and independently, as if 4 frequency counters were used. The instrument displays an adequate number of significant digits that is automatically determined based on the resolution of the measurement. The statistical screen, as its name suggests, shows the main statistics individually for each input. Such statistics include average value, min and max values, peak-to-peak range, and others. The graphs screen displays results in graphical form. As the measurement progresses, the graphs are constantly updated with new samples. You can hide and show individual inputs, which is useful when several graphs are too close or too far from each other. Apply basic smoothing to see trends, and show statistics below the graphs. You can also check particular points of interest on the graphs using tools such as cursors, zoom, and pan. The histogram screen of CNT-104S allows you to observe the distribution of samples for each input. The horizontal axis represents measured values, and the vertical axis shows the number of registered samples with that values. Now we can make some conclusions. The signal on input B has the smallest short-term variations, while the signal on input A has the biggest. This is clearly visible on the graphs and also in the standard deviation field in the statistics. At the same time, the signal on input B has a noticeable frequency offset from the nominal 10 MHz. Probably that source of the 10 MHz signal is faulty or needs calibration. The signal at input D has the frequency closest to nominal. We can save the results for further analysis. As you see, by doing a quite simple measurement on the CNT-104S, it is possible to estimate important signal parameters and draw reasonable conclusions. Thank you for watching this video. See you next time.